Okay, so for problem 18, we want to know if DFE is isosceles. So keep in mind, to prove that a triangle is isosceles, I need to prove either two sides are congruent or two angles are congruent. Okay, so this is kind of where my mind went. I started to take a look at the given information. So AC is congruent to BC. And then also angle 1 is congruent to angle 2. Now keep in mind that this entire unit we've been talking about isosceles triangles. So the minute they told me angle 1 was congruent to angle 2, I took a look at this top triangle, and it's a small little isosceles triangle. So I thought, well, if two angles are congruent, then the sides opposite them would also be congruent. So I wasn't sure if that would help me. I pulled out the triangles that I saw that contained those two sides. So that was side CE and side DC. Okay, and that was from angle 1 being congruent to angle 3. Because I pulled out these triangles right here. So here's my pink triangle that I pulled out right here, and here's my blue triangle that I pulled out. Okay, so I also noticed that when I pulled them out, they're overlapping triangles. And whenever you find overlapping triangles, you're trying to pull out the reflexive side. So I found this reflexive angle. And then the last piece was the piece that they told me. So they told me that AC, which is right here, was congruent to BC, which is over here. So putting all this together in a proof. So the first step is going to be given, and that's my green side that I kind of double checked. I have my reflexive angle, so I kept that orange. Angle C is congruent to angle C, and that is reflexive property. Any angle is congruent to itself. I also then put down that angle 1 is congruent to angle 3, given, and then I put down that CE is congruent to CD, because if two angles in a triangle are congruent, then the sides opposite are also congruent. This is shorthand for this right here. Okay, so if two angles are congruent, then the sides opposite are congruent. After I did all that, I realized that I had enough information. So triangle ACE is congruent to triangle BCE, and that is by side angle side. Once these triangles were congruent, I thought to myself, okay, so how can I possibly get this little orange triangle to be isosceles? And I took a look at angle 1 and angle 3, and I noticed if I continued these right here. So because angle 1 and angle 3 are congruent, and because I have this angle, angle CDB, which is right here, is congruent to angle CEA, right, this blue angle, and again, I'll zoom in over here, this blue angle right here, right? So because those blue angles are congruent to each other, and then because these purple angles are congruent to each other, by the subtraction property, these orange angles would also have to be congruent to each other. So I had to pull out those blue angles. So in step 6, I'm going to say angle CDB is congruent to angle CEA. And that is because if triangles are congruent, then corresponding parts are also congruent. And then my last step is, because I know, I'm going to circle this in green, because I know angle 1 is congruent to angle 3, and because these bigger angles are congruent to each other, then I know that angle EDF is congruent to angle DEF. and that is if congruent angles are subtracted from congruent angles, then the differences have to be congruent. And if those angles are congruent to each other, then triangle DFE is isosceles. If two angles in a triangle are congruent, then the triangle is isosceles.